This lecture is going to be on electric charges and forces involving electrostatics. Here it's important that we realize the real basics go a long way. That like charges will repel and unlike charges will attract. That when we look at charge, we're really looking at a fundamental property of matter, and it's going to be only negative or positive. I guess one could argue that neutrality would be a zero net charge. But these charges, whether positive or negative, can neither repel or attract depending on the charge. So even the tiniest of charge can lead to tremendous forces, and we'll get into that in a little bit when we look at Coulomb's Law. We're going to be looking at electrostatics at the same concept of how you zap a door handle or a light switch, to that being consistent with what takes place in lightning. Here we have electrostatics and polarization. If I rub this balloon on my shirt, my shirt is going to give up electrons, and the balloon is going to attain the same number of electrons, and we can view that in terms of conservation of charge. So the balloon is negative. So here's where things get a little bit rowdy. I place this charged balloon. The negative charge repel electrons in the wall. Notice the wall doesn't move, the electrons are repelled. As a result of this, polarization occurs because it creates a slightly temporary positive charge, which then allows the balloon to stick. Right? The negatively charged balloon is going to stick to the slightly temporarily positive charges in the wall, and this creates electrostatic forces. Now we'll apply this when we look at Coulomb's Law here in just a moment. This is the same concept of what takes place in clouds. We get these air movements that take place, we separate charges within clouds. The negatively charged bottommost part of the cloud repels electrons in the wall, or in the floor, and then creates a temporarily positive charged ground. We'll get into that when we look at lightning. So now we come to Coulomb's Law, and this is kind of the end-all be-all of electrostatics, that the electric force equals this constant K value times two charged particles. Now if they're both positive, the force would be a repulsion force, and if they're opposite, they would be an attraction force. I guess it could also be negative. So positive or negative, they'll repel. If they are opposite charges, they will attract at some distance. So we have to understand here that this r squared is very significant, that distance is just much more important, because as soon as I start squaring values and numbers, let's just say electric forces decrease or increase very quickly. So if I'm decreasing r squared, I'm going to be increasing the electric force. In other words, if I put two charged objects near each other, they are going to either repel or attract based on their charges a lot more than if they are at some distance apart. Here we looked at the electroscope, but we got to do a couple different labs with the electroscope. Essentially, we charge an object by friction, whether it was a balloon or a plastic, glass, or a rubber rod, and then we placed it near the electroscope. And here's what takes place. I have this negatively charged balloon, whatever my object here. In this case, in the picture, it's a rod. These electrons are going to repel electrons in the electroscope. Those electrons in the electroscope then move down to the foil leaves. Because they both are negatively charged, they spread apart. So we see the result of electrons moving. We do not see the electrons moving themselves. So here's what happens when I charge by contact. I transfer some electrons from the charged rod onto the electroscope itself, and I can actually end up with a net negative charge, and this leaves them repelling each other. So we see once again the result of net force. And last but never least, if I then charge this by induction, I can actually charge this object by placing my finger on here and a charged object near it, and I can take some excess electrons and the leaves will repel also. That concludes the final lesson of electrostatics.